Hi everyone. So I put together a little video here to give you some extra tools to make translating word problems a little better. So here's some tips and helps that will get you started on word problems. The first one is when you read the problem, I didn't write it down, but you should read it really carefully. Read it a couple of times and make sure you understand all the words, understand all the parts. There may be words you have to look up in the dictionary. If you're not clear on what it's saying, then it'll be very hard to translate. So read it very carefully and make sure you understand what it's saying. Second thing, read it again and try to figure out your unknowns. As you figure out your unknowns, it might be asking, okay, what's the cost? Or it might be asking how big is the object, or how many people there were. So you're looking for an unknown question. And when you get that question, assign a variable for it. For example, you may say x equals the cost. Or you may say n equals the number of people. Always start every word problem you do by picking a variable for the unknown and then explaining what the variable means, like cost. Or explain to me that n equals the number of people. Write that down every time. Don't skip that. I have lots of students who get the word problem wrong. They do all the algebra right, they do the equation right, and they get the right number, but they get it wrong because they don't know what the number means. And this is how you prevent that. Explain the variable at the get-go. Sorry about that. Next, identify any math that needs to happen to the unknown. It may say something like twice the unknown, so you know there's a multiplication, or the unknown plus 10, so you know there's an add. So in a lot of times, you can identify what has to happen by looking for keywords. One of the big keywords for equations is the word is, or a math sentence. But another more subtle form of finding the math is reading a word problem that involves some kind of formula. There may be some formula like what is the cost, or what is the area, or what is the perimeter, or what is the distance. And there's 4 really important formulas for that. So I have a good video for you. You should watch to learn about these videos. I'm sorry, let me restate. I have a good video for you to help you build up this understanding of the formulas. There's 4 of them that are pretty basic that you should build on. Let me show you. Okay, open up, Mom. Scroll down to chapter 2. Open up chapter 2. And we don't need 2.4. We need 2.3, but we do need 2.4. And this first video, translating words into expressions, he does a great job in there of helping you translate, but also talking about the formulas. So, for those of you who are not in the algebra class, you just happen to find this on YouTube. Okay, I had to skip by the commercials and stuff, but notice down here, it's on the Math Fortress. So this guy's YouTube channel, translating words into symbols, he calls it something slightly different. But he has this formulas. So that's a really good video to help with the 4 main formulas. I encourage you to check that out. And just one last reminder for you in the algebra class, it's under section 2.4, happens to be the first video that does the formula. The second one he does is for equations. That's also a really good one. The third one's a little bit more advanced, but also really good. So 3 great videos that'll help you with this translation as well. So that's another tool for you. All right, the third strategy or tool to help you with word problems is to write everything down. Think about it as like a puzzle. When you're solving a puzzle, what do you do first? You dump all the pieces on the table. So take the word problem apart and separate all the pieces and organize the different pieces that you have. Gather up the different information from the different pieces. And then you put all of it together to, in the end, build your equation. It does say it takes some practice. This is not something you're born doing. You're not going to know how to do it at first. So practice with the easy ones, and then build. Each time you do a new problem, do a harder word problem, a little harder each time, and you'll build the skill. It'll come with time, but it's a lot of practice, a lot of trial and error. You make mistakes every once in a while. Just press through them, and you'll be able to start translating word problems. For example, let's translate this one. Renting an ice skating rink for a birthday party costs $200 plus $4 per person. The rental cost was $324 in total. So whoever paid for this party, that's what they paid, $324. How many came to the party? Well, that's the first thing we should look for. We should look for the unknown thing. Now, often the unknown thing is directly in the equation. How many came to the party? Okay, so that's a good place to begin. If you remember, the very first thing is figure out the known, assign a variable to it. That's what I'm going to do. I'm going to call it n. I guess I don't like the red, though. I'm going to let n equal the number of peeps. I'll say people. People at the party. All right. Now, one more thing about this is an abbreviation. In the old days, today you guys think of that as a hashtag. But in the old days, that symbol was an abbreviation for the word number. So it has that symbol has two meanings. It means number. It also means hashtag, but I'm going to use it for number, of course. Okay, now I'm looking for an equation. I'm going to start collecting facts. Okay, I know the party cost $200. I know it costs. Wait, it doesn't cost $200. So that's important. See, I wasn't looking at the problem carefully. The whole party didn't cost $200. The whole party cost $324. So if I'm not paying attention, I could mess myself all up. What is the 200 thing, though? The birthday party cost $200 plus $4 per person. Okay, so the $200, what is that thing? The $200, maybe it's like a deposit. It's not a deposit. It would be like a fee, an upfront fee. That's what I'm going to call it. We have to pay the fee first. But we also have to pay per person. Okay, that's another fact. It is $4 for each person. Okay, so what I'm doing right now is I am listing all the different facts, and I am searching for a piece to the puzzle. The different pieces I have, I listed them, and I see the crucial thing. It involves two things: how many people and the total cost. All right, so now I'm going to start looking for the equation, the mathematics. And cost seems to be the big theme. I got to figure out the cost. Now, what we need is kind of like a verbal model, a word sentence, a word formula that helps us explain the cost. There's a lot going on here. Not too much, two things going on. So it seems like the cost is made up of the fee plus, right there is the word plus, something else. Cost per person. Okay, now sometimes if you can analyze the words and come up with the idea of the big thing, in this case the big thing is cost. This is, in math we call this a verbal model. It's kind of like a baby equation. It's a word equation. But once we get the word equation, we can use it as a baby step to the algebra equation because we know the cost. is $324. We know the fee was $200 plus we got to figure out the cost per person. Now, how do we do that? It has something to do with $4. So what do we do with the $4? Is it just plus 4? Well, that means 200 plus 4 equals 324. No, that's not correct. 204 does not equal 324. Something else is going on here. If we had one person, it would cost $4 for that one person. If we had 3 people, well, each of those 3 people would cost $4. So wait, that's 3 times 4 would be $12. So we have to multiply the $4 times the number of people we have. So this cost per person had a hidden math problem in it. We had to multiply. We have to multiply $4 times each person. So if we have 10 people, we have to pay $4 times all 10s. We have to go 4 times 10. If we have n people, we have to go 4 times n. And that does it. We have built the equation for that word problem. We turned that really hard word problem into a basic equation. Now, we're not going to talk about solving these yet. All we're talking about right now is translating. So we got the translation. We turned the words into an equation. Pretty soon we'll talk about how to solve it, but the solving is easy. This was the challenge, and if you get this, you're well on your way to doing solving equations and solving word problems. Let's try one more. Valley High School has 13 science instructors on its faculty. The number of science instructors is 5 more than the number of math instructors. How many math instructors are at Valley High School? Okay, so we want to read it really carefully. We have science instructors, we have math instructors. There's a question here. What's the question? That is the number of math instructors. Oh wait, that's not where the question is. The question is down here, how many math instructors? Okay, so remember, that's a good place to start. Step 1 is figure out your unknown and assign a variable to it. So it looks like, let's call it x this time. When you pick your letter and assign a letter to your unknown, you can pick any letter you want. Last time I used n, this time I'm going to use x. And it's the number of math instructors. Okay, now let's start writing down our facts. We have 13 science instructors. And we do not know how many math instructors are. That's a question mark. But we do have a clue. The science instructors is 5 more than the math instructors. Okay, so we have more science than math. Okay, now, this is, when we start thinking about equations, this is an important little ingredient here. We know the answers for the math instructors has to be smaller than 13. Now, you could maybe intuitively figure this out with number sense and come up with an answer, and that's good to have. But I want to train you to start thinking algebraically, and that means making an x and making an equation with x. You want to build your algebra thinking now on the easier ones so that when we do hard ones later that you cannot do with number sense, you will be able to do them with algebra. That's the whole point of the algebra equation, is it can solve the hard ones that are, intuition and number sense can't solve. Okay, so remember that. More science instructors than math instructors. Okay, so I also see a key word. I'm looking for equations, I'm trying to piece together things, but I see the number of science instructors is 5 more than the number of math instructors. Well, the is giving me the suggestion of an equation. Okay, so I want to start looking for my math equation. I've got some clues here. I want to build off of those clues. First clue, number of science instructors. I'm going to abbreviate. And then I have that key word, is. And then I have math over here. I have 5 more than. Okay, what's the number of math instructors? How do I translate that? Oh, let me just write it down. 5 plus the number of math. So what I've done here is I've taken the word problem and I'm kind of simplifying it into smaller bits. I'm starting to move the words into a pseudo-equation. This is kind of like a verbal model for the equation. It's part words and part math. And that way I can start translating the words into math a little easier because I see the science instructors. I know already that that is 13 science instructors. I see that there's 5 more, so I'm adding 5 to something, and I'm adding 5 to the number of math instructors. Well, what's the number of math instructors? That I don't know, but I'm representing it with X. We did it. That's it. That is an equation that will translate this word problem. Now, it's another thing to solve it. This one happens to be easy to solve compared to the last one. And I'll give you kind of just for sake of time. It turns out it's 8, but we're not interested in the answer. I want you to think about it in terms of how do you translate it. Okay, I hope that was helpful. All right, I changed my mind. I was trying to keep it a little bit short. I skipped a problem, but I changed my mind, decided to put in one more problem for you. Now, if you were with me in class today, you've already done that problem. But for those of you who are finding this video and weren't in class, of course, you didn't see it. So let's add that and do one more example here. Peter's lawn mowing service charges $10 per job and 20 cents per square yard. Peter earns $25 for a job. How big was the lawn Peter mowed? Translate that into algebra. Okay, now let's start at the beginning. Make sure you read it and understand all the details. Maybe the whole idea of square yards is not familiar to you. You might have to brush up on that. And so I think we'll beef that up a little bit. But I'm going to start at the beginning and look for the unknown and assign a variable. Okay, now sometimes the unknown is not obvious. Sometimes there's a hidden unknown. So in order to get the main unknown, you have to solve for a secondary unknown that's kind of hidden in the words. This one doesn't really have that so much. And also it has the question itself. The question is, how big was the lawn? That's our unknown. So the question is what we want to solve. That's usually a great place to start. And so let's let L equal the size of the lawn. Okay, now wait, how do we measure the size of a lawn? Now, if you're not familiar with the idea of area, if this is 1 yard and that's 1 yard, this would be 1 square yard. 1 square yard. Oops. We'd say square yard, or we would say 1 yard to the second power. Both ways are notation that we use to do that. Now, if we have 1 yard, Peter's going to charge 20 cents to mow that one little piece. But if there's another one, he's going to pay 20 cents. He's going to be asked to be paid 20 cents for each. So there's 2 of them. If there were 3 of them, he would want 20 cents for all 3 of them. Well, wait, mathematically, how much money is that? 20 cents and 20 cents and 20 cents, that's like 20 cents times 3. So that would be 60 cents for all 3 of those. But what if there are, how many are there in this lawn? Well, we don't know how big the lawn is. We're calling it L, and what we're going to have to do just now to clarify a little bit is we're going to have to count up all the square yards. But the problem is we don't know how big the lawn is. So when we measure the size, we're going to have to measure the size of the lawn in square yards. And so if there's L of these little boxes, Peter would be charging 20 cents times each. Okay, so that's something that's going to play into the story and the equation. But there's more. Let's keep breaking it down, pour out all the pieces and start organizing the pieces here. There is another thing I see. It's talking about $25. Okay, Peter earns $25. What does that mean? For the whole job, that's his total pay. There's another thing here. There's $10. What is the $10 things? Is that what Peter charges? Yes, that's what he charges. It's not the only thing he charges, but it's part of the charge. He comes to the front door, and before he starts, he requires $10 just to be there. So, this is very much like the first problem we did. You could think of that as a basic fee. So Peter charges $10. And then there's also this thing with 20 cents. We'll have to figure that out. Okay, so to me it looks like we've broken out all the different parts of this problem. Now we need to start thinking, how can we build an equation? Now it's not as easy as the last one. I don't see the is word. And so in this case, since that word isn't there, it's not as obvious what our equation is going to be. We're going to have to use some common sense and kind of build it. So if you were Peter and you were going to somebody's house and you were going to charge them and say, what's my pay? You'd have to figure out the pay formula. Let's do that. So, but we're going to start with just the idea of the pay. Now, some of you know the equation already. You can build the equation just from that previous discussion and you're good to go. You can translate it and be done. But a lot of you are looking at it and saying, I'm not sure yet. So this is another trick of trying to get an equation, and it's building a verbal model. A verbal model is words that break down the word problem into simpler words that are part words and part math. So pay, simple word, equals. There's some part math there. Now how does Peter come up with the pay? Well, he has 2 parts to it. There's a fee. and there is the fee, and now sometimes in math, and is plus. And in this case, there is the fee and the cost of the square yards. So we do have to add something. Cost of square yards. Now, this takes a little bit of practice, but it's kind of common sense once you understand how Peter works. He goes and he makes them pay two things. There's a basic fee, and then he charges them for the size of the lawn. The bigger the lawn, the more square yards there are. They have to pay 20 cents for each one. That grows the amount of pay on a big lawn. If the lawn is small, then the square yards is small. But this idea of building a little model like this is our baby step to an equation. Because we know the pay, he got $25. And we know the fee, he got $10. And the cost of the square yards. Now this is kind of like a hidden unknown, not quite, but there is some hidden math that we have to do here. Because I'm going to make it green because we're talking about the grass. How do we figure out the cost of the square yards? Well, the cost of the yards is the number of square yards times the price of each one. If you watch that video, I suggested he talks about that. Cost equals the number times the price. Or you can do price times number. That's what I did. So, the price is 20 cents. Or $0.2 times the number of square yards, which we don't know. So we have to use a formula for that. That completes it. We turn the entire equation into the entire word problem into an equation. 25 equals 10 plus 0.20 times L. There it is. That equation will help us solve that word problem. We'll talk about solving later, but right now our whole focus and concentration is how do we translate words into algebra. Hope that was helpful. Study hard. YouTube has other examples that are good to look at that'll build your knowledge base and your experience and confidence. So anyways, good luck with this. I'll see you later.